Hello everyone, welcome to the session of Theory of Computation or Formal Languages and Automata Theory. In today's session, we are going to discuss about post correspondence problem and modified post correspondence problem, and also we will discuss about the classes of the problems, that means P, NP, NP complete and NP hard. Okay. So let us start our discussion with this post correspondence problem. So the first thing is that it is an undecidable problem, right? So in the previous session we have seen what is a decidable problem and what is undecidable problem. Okay, and also we discussed about the halting problem, so which is also comes into the category of undecidable problem. Right? So in today's session, we are discussing about the another undecidable problem, which is called as post correspondence problem. So this problem was introduced by Emil Post in 1946. Okay. So here we will see why this particular problem is considered as undecidable problem. Okay. So before that, let me explain what is this post correspondence problem. So here consider that we are having the two lists P and Q. So capital P and capital Q are the two lists consisting of some strings. Okay, so let me consider that here P equal to x1 comma x2 comma x3 comma so on xn. So these x1 x2 x3 so on xn are the strings or items that belongs to the list P. Okay, and similarly we are having some sequence of strings or items, okay, in a list Q. Okay, so here let me consider Q is equal to y1 comma y2 comma y3 comma so on yn. So these are the sequence or sequence of items or sequence of string which are there in the list Q. Okay, so here if we observe these strings which are there in P and Q are defined over alphabet set sigma. Okay, so let me explain with one example. So here I am having sigma alphabet is equal to 0 comma 1. So I am having the alphabet set sigma is equal to 0 comma 1, right? So here I am having a list P which is consisting of sequence of strings like 0, 1, 1, 1, 1, 0, 1, 1, 1. Okay. So here I am having the four strings. Okay. So first one 0, 1, next one 1, 1, next one is 1, 0, and next one is triple 1. Okay. So these are the four strings x1, x2, x3, x4. Okay. So if we observe these x1, x2, x3, x4, they are defined over alphabet set sigma. Okay. So here in P, how many strings are there? How many items are there? 4 items. So in post correspondence problem, if the P is having 4 strings or 4 items, then the list Q must also contain 4 items or 4 strings. Okay. So let me consider the strings in a list Q are 1, 1, 1, 0, 1, 1, 0, and 0, 0, 1. Okay. So here if you observe Q, it is also having some sequence of strings or items. Let me say y1, y2, y3, y4. Okay, y3, y4. So if you observe this y1, y2, y3, y4 is defined from alphabet set sigma. Okay, so the strings in a queue are also defined over alphabet set sigma. Okay, so this is the point that we discussed till now. So p is equal to x1 comma x2 comma x3 so on xn, and q is equal to y1 comma y2 comma y3 comma so on yn. So these are p and q are the list containing some sequence of strings or set of strings defined over some alphabet set sigma. Okay, now this particular instance of PCP has a solution. Okay, if for some I1 comma I2 comma I3 comma so on Ik, okay, where 1 less than or equal to Ij less than or equal to n, the condition xi1 xi2 comma xik is equal to yi1 comma yi2 comma yik satisfies. Okay, so what we have to do here is that we have to find out the sequence in which we can arrange the items in each list, okay, or strings in each list, so that we will get same string in P and Q. Okay, so here if you observe, here we are finding the sequence, right? I1 comma I2 comma I3 so on Ik. So we have to find out the sequence such that when we organize the strings in that particular sequence, then the string that belongs to Q, that means the string that is obtained from P, and the string that obtains from Q, both are equal. Okay, both must be the same. Okay, so that sequence we need to find out. Okay, so that particular problem is considered as a post correspondence problem, right? So from a given list of strings, whenever we can able to find out the sequence, okay, by arranging the strings that belongs to both the list in that sequence, we will get same string. That means we will get the strings from P and the strings from Q will become equal. Okay, so whenever we have such sequence, then that particular instance of the PCP is considered as a solvable one. That means that particular problem is having a PCP solution. Okay, so let me consider here one example. So here we are having the two list. Okay, so this is the list. Okay, so list A, we are having one, next another item or another string 1 0 1 1 1, and next one is 1 0. So let me call it as x1 x2 x3. Okay, so the list A is given. In that we are having the sequence of items, that is 1 comma 1 0 1 1 1 comma 1 0. That means it could be perceived as x1 comma x2 comma x3, right? And similarly we are having the list P, which set of or sequence of items or strings, let me consider as y1 y2 y3. Okay, so what we need to do here is we need to find out the sequence, okay, in which if we arrange the items in list A based on that sequence, and if we arrange the items of list B in that sequence, then both the strings will become equal. Okay, so both the strings become equal, right? So let me explain here. So first thing here, we are having 1, right? So if we select this particular index string in list A, then definitely we must select that particular index string from list B. Okay, so that is one rule while finding the solution. So here when we are selecting a particular index string in a list A, then you have to select that particular index string from list B also. Okay, so we have to arrange the strings of list A and list B in such a way that we will get same string. Okay, so to explain this, let me consider. Uh, Let me consider here. I am taking x2. That means this x2 from list A. Okay, so I have taken like 1 0 1 1 1. Okay, so that I am representing in a numerator part, and then in denominator part I am representing the item that belongs to list B. Okay, so as I have selected x2 in list A, then I have to select y2 from list B. Okay, so as I mentioned, the index must be the same. So I got 1 0 in the denominator part. Okay, so numerator part is nothing but string from list A, and denominator part is nothing but string from list B, right? So here if you observe, the first symbol is 1 in list A is matching with the first symbol in list B. Okay, the next one. The second symbol in list A is 0 and it is matching with the next second symbol in list B, that is 0. So both are same, right? So next third symbol here in A is 1, but we don't have the third symbol in B, right? So what we have to do here is that next time when you select the sequence, you have to select the sequence in such a way that the third symbol in A must match with the third symbol in B, right? So to get a third symbol as 1 in B, what we have to do here is that we have to either select x1. Okay, because if we select x1 means from list B we will get 1 1 1 triple 1. So by doing this, what will happen? The third symbol in A will match with the third symbol in B. Okay, right. Next one is that you may also select x2. Then what will happen? If we select x2, what will happen? This is the first part, right? So this 1 is matched with this. Okay, this 0 is matched with this, right? So next iteration what we have to do here is that the third symbol in A is 1. So definitely in B you must get the third symbol as 1, right? So the one possibility is that you can select x1 in the next case. So if you select x1 you will get 1, okay, in the numerator part, and in list B you will get 1 1 1, right? So here if you observe, the third symbol in A is matching with the third symbol in B. Okay, in B, and moreover we got this one, fourth one matching with fourth symbol in B. Next fourth one, fifth one in A matching with the fifth symbol in B, right? So we got one extra one in A part, right? So now what we have to do here is that again we have to select, okay, we have to select the string in both numerator and denominator part, that means from list A and list B, such that we will get the matching sequence of symbols. Okay, so if I take here, I am having 1, right? So definitely when you select the next symbol or the next string in denominator part or from B, it must have 1, right? So it must have a 1, right? So what we will do here is that we can again take x1. So what will happen if we take x1 here? We will get 1 and 1 1 1. So what will happen here? So this one will cancel with this one, okay, and next this one will get cancelled with this one, okay. So we got one more extra one in the denominator part, okay. So then while selecting the next string, that means the numerator part must have that one, okay. So you have to follow such pattern Okay, so while matching the sequence of strings, right? So here, come back to the point. Here I have selected x2, okay, x2. So I got 10111 in numerator part, and I selected that y2. I got that y2 in the denominator part. So the moment when I select this, the 1 in A matched with the 1, the 0 in A matched with the 0. Okay. Next we got 3 extra 1 in A, right? So next when you select that next string, in the denominator part we must have 3 ones, right? So if you observe the pattern where we are having 3 ones in a list B, it is in index 1 or it is belongs to y1, right? So we have to select y1 in the denominator part. As it is y1, we must select x1 in the numerator part, right? So that will get 1. Okay. Now if you match the symbol, third A1 is matching with third symbol in B, fourth one matching with fourth symbol in B, fifth one matching with fifth symbol in B, right? So now if you observe, in the numerator part we got 1, so additional 1 it is there. So while selecting the next pattern in B, you must have that 1. Okay, you must have that 1. Okay, so what we can do here is that we can take the numerator part as x1. That means we can select x1 from list A and y1 from list B. So you'll get 1 triple 1, right? So this one will be matching with this one. Okay. Now next one. Now here we are having 1. Okay, and denominator part we are having 2 ones, right? So while selecting the next string, sequence of string, the numerator must have the 2 ones. Okay, the numerator must have the 2 ones. So already this one we are having. Okay, this one we are having. So in the numerator we must get 1 1. Okay, so we are having, if we select x3, we will get 1 0. Okay, so if we select x3, then the y3 part will become 0, so it comes into the denominator portion. Now this one is matching with this one, this one is matching with this one, and this 0 is matching with this 0. So if we observe the string that is there in the numerator part, it is 1 0 1 1 1 1 1 1 0. Okay, and denominator part it is also having 1 0 1 1 1. Okay, 1 1 1 0. Okay, so if you observe, we found the index that is 2 1 1 3. Okay, that means we have first selected x2 y2, then we selected x1 y1, again we selected x1 y1, and again we selected x3 y3. So the sequence is 2 comma 1 comma 1 comma 3, right? So we found the sequence, okay, in which if we organize the strings in list A based on that sequence and the strings of list B in that sequence, you will get the same string. Okay, so you'll get same string. So here we can say that this post correspondence problem is having the solution 2113, or you could write x2 x1 x1 x3 is equal to y2 y1 y1 y3. So hence the solution is 2113. Okay, so you could also write like I equal to 2, j equal to 1, k equal to 3. Okay, so that was the problem. So here if you see this statement, so here what we are finding is that we are finding the sequence I1 comma I2 comma I3 so on Ik. Okay, such that if you organize the items of P in that sequence and items of Q in that sequence, then the strings will become equal. Okay, then the strings obtained in that sequence from P and Q will become equal. Okay, so this is the one of the problems of PCP and its solution, right? So here if you see here, we cannot start with 1 0. That means we could not start with x3. Why? Because if we take 1 0 x3 here, okay, then y3 will be 0. So here the string that belongs to list A is starting with 1 and the string that belongs to list B is starting with 0. So there is a mismatch in the first symbol. So we could not have a sequence that is starting with x3. Okay, but you may have the sequence that is starting with either x1 y1. Okay, this is one, or you may have the sequence that is starting with x2 y2. Okay, 2 y2, right? Okay, so while selecting the index of a particular item in both the lists, check that the symbols that you are considering in the list must be matched. Okay, must be matched. Next one, second problem. So here we are having a list M is equal to ABB, comma AA, comma AAA, and N is equal to BBA, comma AAA, comma AAA, right? So if you organize, okay, we are having list M and N. Okay, in M, X1 is AB, X2, ABB, X2 is AA, X3 is AAA. Okay, and Y1 is something like BBA, Y2 is AAA, and Y3 is AA. Okay, so this is the thing, X1, X2, X3, right? So what we have to do here is that we have to find the sequence such a way that if you organize these sequence of strings in that sequence, both the strings that belongs to M and N will become equal. Okay, now so let me start here. So here I couldn't start with x1 because if I take x1, the first symbol will be A, okay, and the first symbol in second list will be B. So there is a mismatch, right? So if I take the x1 in the numerator part, okay, as a first sequence, B, B, A. In the denominator part, I will get y1. So here there is a mismatch. So A is there as the first symbol, B is there as the first symbol in list 2 or list N. So there is a mismatch. So you could not start with the x1, right? So you may start with either index 2 or index 3. Okay. So you may have either x2 y2 combination starting with this, or you may have x3 y3 combination. Okay, so here in the problem I have taken the sequence as 2, so I am writing the sequence as 2. Okay, so sequence 2 means I have taken x2, so x2 means it is AA in the numerator part. Since I have taken x2 in the denominator part, I will get y2, which is nothing but AAA, right? So if we match the sequence of symbols in numerator and denominator, we will get AA matched, second A matched. Okay, now the next symbol, that means extra symbol in the denominator is A. So definitely when you select the next string in a numerator part, it must match with that A. Okay, so here you may have the choice, you can start with either x1, x2, x3. Okay, so if we start with x1, you will get ABB, ABB. Okay, since we have selected x1, the next sequence, so definitely you will get y1 in the denominator, that is BBA, right? So now if we compare, A is matching with A, that means numerator and denominator are matching, then b numerator is matching with denominator, again b numerator is matching with denominator, right? Now we get one extra a in the denominator part, so definitely when you select the next sequence you must get a in the numerator part, right? So by considering that sequence you may select either x1 or x2 or x3, right? So if we select x3 here, we will get a triple a. Okay, since we have selected x3, we have to select y3 in the denominator part. Now if we compare the sequence, a in numerator and denominator is matching, a in numerator and denominator is matching, a is matching, right? So if you observe, we got the string in the numerator part as a, b, b, triple a. Okay, right? And next in the denominator, we also got same string a, a, b, b, a, a, a. Okay, so both are same. Okay, so here we could say that this PCP is having the solution 2 comma 1 comma 3. Okay, so 2 comma 1 comma 3 is the solution, right? Or you could say like x2 x1 x3 is equal to y2 y1 y3. Okay, so actually this PCP is a non-deterministic, so that means it is not going to have one solution. You may have different solutions for it. So I have taken one combination such a way that I got both the strings as same. Okay, so there may be another sequence that would produce the same strings with respect to m and n. Okay, so that's why this is a non-determinism problem. Okay, next one. So this is the example 3. So just look at this example. Here we are having a list W and list X. Okay, and we are having the items A, B, 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 A. So let me consider here as W is there, X is there. Let me consider it is something like P1, P2, P3. Okay, and this part I am considering Q1, Q2, Q3. So is this problem is having a PCP solution, that means post correspondence solution? So here we need to try out the possibilities. So first if we can start with the P1, that means if we start with the index 1, what will happen? We will get the numerator part as A, B, and denominator part you will get as A, B, A. So what will happen here? The first symbol is matching in numerator and denominator, but if we consider the second symbol, it is A in the numerator and the denominator it is B. So if we take the index as 1 as a starting one, we cannot get the sequence. Okay, so then next we may either start with so we can only start with the sequence 2. Okay, so the first sequence could be 2, that means you have to take P2. So when you take P2, it is numerator part will be BB and denominator part will be BBA. So now if you observe, first B is matching with second B, sorry, first B in numerator is matching with first B in denominator, second B in numerator and denominator are matching. Next we got one extra A in the denominator part, right? So now what sequence we have to select? We have to select the sequence such a way that we will get A in the numerator part, right? So in the A numerator part means here there is a possibility that you could select A, B, okay, in numerator, that means 1. So you have to select y1 in denominator, A, B, A. So what is happening here, you could see. So this A denominator is matching with numerator, okay, but this A is matching with this A, this B is matching with this B. Okay, now we got one more extra A. Okay, so what we can do? we have to start with A. So if we select 4 A's, what will happen? If we select 4 A's, that means if we select the sequence as 3, what will happen? You will get 4 A's in the numerator part and 1 B in the denominator part. So which makes the strings unequal. Okay. So the strings will not be equal, right? So we could not select with the sequence 3. Okay. Now if we select 2, what will happen? You will get B in the numerator part, but here we are having A in the denominator part, so this will not match. So you could not take the sequence as 2. Okay. So you can continue with the sequence 1, that is A, A, B. So as you selected A, A, B, then you will get A, B, A, A, B, A. So now see what will happen. The A numerator will become equal to the new denominator. Next we will have A, and next we will have B, B, and then we got extra A. So if you keep on repeating, you can't get the string of same length, okay, and that are of same type. That means they will not become equal. So this PCP is not going to have the solution. So this PCP is not having the solution. Okay. So no solution for this PCP. Right. So I think you got an idea what is this post correspondence problem. Okay. What is this post correspondence problem? So you will get the strings of same length. Okay. And that must be equal. Okay. Obviously, when we are getting the two strings are equal, definitely they are of the same length. Okay. So next one, we are having one more flavor of this post correspondence problem, which is called as modified post correspondence problem. So it is same as the post correspondence problem, but there is a change that here the sequence must start with 1. Okay. The first sequence must be of index 1. Okay. Or must start with the first index. Okay. Whereas in the previous case, you may have the solution that is starting with the different index, right? So in the problem 1, we got the first index as 2, right? So we got the first index as 2. In the second problem, we again got the first index as 2. Okay. Third problem, again we got the first index as 2. Anyhow, we didn't get a solution. So here, in modified post correspondence problem, the I1 must be 1. That means the first index must be 1. After that, you may have any index. Okay, it could be either 2 or 3 or 4, it doesn't matter. But the first sequence must start with the index 1. Okay, so that is the thing. So to understand here, consider that we are having a list A and list B. So this is list 1, X1, list second item in list 2, X2, third item is X3, okay, Y1, Y2, Y3, Y1, Y2, Y3. So as modified post correspondence problem, what we have to do, definitely we have to start with the first index items, right? So if I take the first index as 1 means I am selecting X1 in the numerator part and I am selecting Y1 in the denominator part, right? Now, so 1 in numerator, 1 in denominator is matching, 1 in numerator, 1 is, 0 in numerator and 0 in denominator is matching. So next you could either start with, next you could either select index 2 or index 3. Okay. So if we select that index 2 means you will get 1, 1, 0 in numerator and denominator will get 1, 1. So 1 is matching, 1 is matching, 1 is matching in numerator, 1 is matching in denominator, so you will got 0. So definitely when you select the next string, the denominator part must be 0. So where we are having 0 in the denominator part, it is y3. So definitely it must start with y3 in the next sequence. So y3 will be considered. Since we are considering y3, we get x3 in the numerator. So what will happen? 0 will match with this 0, 1 and 1 is matching, 1 is matching, right? So we got the string like 1 0 1 1 0 1 1, right? So what was the sequence? It is something like 1 comma 2 comma 3, right? So this MCP is having the solution that is 1 comma 2 comma 3. Okay, so that is the change. So just remember this change while considering this MCP. Okay, modified post correspondence problem. Okay, So here, that's it for today's session. In the next session, we will discuss about the problems. That means computational problems, how it can be divided into the classes like P problems, NP problems, NP hard problems, NP complete problems. We will discuss that part in the next session. Okay. So if you feel any difficulties with this PCP and MCP, so let me know once so that I will clarify all your doubts, and if required I will explain another problem in the next session so that you will get more clarity on this concept. Okay. So thank you for attending this session. Have a nice day.